Today we start Chapter 9. Chapter 9 is called Solving Systems of Linear Equations. Basically, when we're talking about a system of linear equations, we're talking about two linear equations that we consider and try to solve at the same time. Let's look at an example of when we would need to do this. So, a system of linear equations. Here's what it looks like. We consider this problem where we know that Madeline has 15 coins, they're all dimes and nickels, and they're worth $1.40. And we want to find out how many of each kind of coin does she have. So how many nickels, how many dimes? So we decide to try to use algebra and we make variables and we say that x is going to be the number of dimes she has and y is going to be the number of nickels that she has. And so we decide that we're going to try to write an equation. So we come up with this equation, x plus y equals 15. And that's great, right? We know that there's 15 altogether, so dimes and nickels together, you get 15. Wonderful. So then we try to solve, and we're like, okay, well, maybe she has one dime and 14 nickels. That seems like a great idea. So 1 plus 14 is 15. But then someone says, well, there could be another solution. Maybe there are 10 dimes and 5 nickels, and that would work too. And you know from the last chapter that when we have these equations in two variables, there are lots of different ordered pairs, xy pairs, that will work. But Madeline doesn't have, different numbers of dimes and nickels. She has one number of dimes and one number of nickels. So there's only one answer to this question. And to find the one answer, we stop needing just one linear equation and we need a second one to help us find the one answer. So to get one answer for the two variables, we need two equations. So luckily, we have this other piece of information about this situation. We know that if we multiply 10 cents times the number of dimes and 5 cents times the number of nickels and add them together, it should give us 140 cents. And so our number of nickels and dimes, our x and y, they have to satisfy both of these equations in order to actually be a solution. So to find the actual solution for two variables, we're going to need two equations. So if we talk about a particular solution, maybe someone says maybe there are 10 dimes and 5 nickels, and so we're going to try the ordered pair 10, 5 in this system. So to see if this works, we'd have to try it out in this first equation, and you can tell right away that if you add 10 plus 5 together, so we're doing the first equation here, 10 plus 5 together, you get 15. So that's great. This works, and we've got, looks like 10 plus 5 could be a solution. But if we went to this second equation, and we put in our 10 and our 5, so 10 cents times 10 dimes plus 5 cents times 5 nickels. That gives us 100 plus 25, and that equals 125. That is not 140 cents. That is what we were supposed to get 140 cents. We did not. We got 125. So this is absolutely not working. 10-5 is not a solution to the system because it didn't work in both equations. So to figure out the actual solution to two equations, we're going to need the ordered pair, our solution, to work in both equations. I'd like you to try one of these on your own. So in a second, you should pause your video and to try to determine if the ordered pair negative 2, 3 is a solution to the system. And remember, for it to be a solution to the system, it has to work in both equations. So you want to do the work out, see if it works. So pause it now and don't unpause until you're all set. So hopefully at this point, we can talk about the work in class if we need to, but hopefully at this point you've plugged this ordered pair in and found out that it does not work in the equation. What our goal in this chapter is going to be is not to just figure out if different ordered pairs are solutions to systems, but rather what the solution is. So there's a few methods, and we're going to talk about one today. The first method is the graphing method. So that's what section 9.1 is about, graphing. So one way to solve a system of linear equations is to graph them. So what I've done here is I've graphed x plus y equals 1 over here, and also 2x minus y equals 8 over here. And so these lines are a graph, a picture of all the points that work in each of these equations. And you can see that these two lines intersect at this one point right here, 3, -2. And so this point works in both equations. So because this one point is the only one you can see from the graph that will work in both equations, we know that the solution to this system is going to be the point 3, -2, because it's the one point that works in both equations. So anytime lines intersect, and you can tell this from looking at a graph, the solution to the system is always going to be one ordered pair, whatever the point is where the two lines intersect. What I'd like you to do now is take a look at this pair of ordered pairs, this pair of equations, this system of equations, which I've taken the liberty of graphing for you. And what I would like you to do is find the solution to this system. So pause your video for a second, take a look at this graph, and write down what you think the solution to the system is. Once you're done with that, we'll go on, and we'll talk about this answer once we get back to class. Now, it is not always the case that lines are going to cross. Sometimes we might find ourselves with parallel lines. So here I have a system of equations that if we made a graph of them, the lines would be parallel. And these are parallel, of course, because they have the same slope. Both lines have this slope of 1/2. So in both of them, they're in y = mx + b form. They both have the same slope, so we know they're going to be parallel. So if we looked at a graph of these two lines, which I've got right here, something you should notice is that because they're parallel, these lines never ever cross. And because they never cross, they have no points in common. So because these two lines have no points in common, this system can't have a solution, because a solution has to be an ordered pair that works in both equations, and here we can't have any ordered pairs that work in both equations because they don't share any ordered pair. This observation leads us to the following result. When the lines are parallel, the system is going to always have no solution. So if we looked at these two lines, these two equations in y = mx + b form, that we know have the same slope, that means they're parallel. This particular system, instead of having a solution like 3, -2, like the first example we looked at, this one has no solution because there are no points where they cross. There's one other situation that's important to look at when we're talking about systems of linear equations. I want to take a look at these two linear equations, and I want you to look at something interesting. If we change them into slope-intercept form, so if we solve for y, I'm going to subtract the 2x on both sides and get y = -2x + 1. And then I'm going to divide by -1 on both sides and get y = 2x - 1. Then I'm going to do the same thing to the other equation. So I'm going to subtract 6x on both sides and get -3y = -6x + 3. And then we'll divide by -3 on both sides and get y = 2x - 1. So you should look at these equations and say, oh, well, they looked different to begin with, but now I'm looking at them, and in reality, they're exactly the same equation. So something that this means is that if you tried to graph these two lines, you wouldn't be able to draw a graph of two lines because they're actually the same line. So if you looked at a graph, you would just have a picture of one line. And what that means is that every point that's a solution to one equation is a solution to the other one, because any point that's on one line is on the other line because they're the same line. So when two equations are the same line like this, and we say that, and they have every point in common, what we say is that they coincide. And when they coincide, because they have every point in common, they have so many solutions. So anytime two lines coincide, so again, that means they are the same line, we say that the system, so this system, 2x - y = 1 and 6x - 3y = 1, we say that this system has infinitely many solutions. So it's not one solution, it's not no solutions, but it is infinitely many solutions. Uh-oh, battery problems. So better finish up quickly. So we say that this has infinitely many solutions. So you can either have one solution if the lines cross, no solution if the lines are parallel, or if the lines coincide, so they're the same line, can be infinitely many solutions. Next time we see each other in class, we'll talk about this and then we'll do some problems. Hope you enjoyed and see you soon.